or you want to do the hypothesis. I want to test the hypothesis. So the bivariate statistical analysis is under you want to test a hypothesis. Okay, so from the name itself, bivariate, so meaning that there are two variables, bivariate, two variables statistic. For example, like we have like, if we want to do, we want to do descriptive statistic, we want to know about only the mean, the average of BMI. So the average of BMI is only one variable involved. So if you have only one variable involved, we call it univariate statistic, univariable statistic. So if you have two variables, so that is bivariate statistic. If you have more than two variables, we call it multivariate statistic. Okay, so today we will focus on the bivariate statistic. We have only two variables by. Okay, this is like a summary. Okay, for the hypothesis testing, just focus on the hypothesis testing. If description, describe the data you have learned during the IBM 1 last academic session. For example, center tendency, frequency graph, so you have learned it before. You also have learned, actually you have learned it previously for hypothesis testing, like ANOVA and all that. But today is only like a revision, and maybe there are certain additional information for all the statistical analysis that you have learned before. So basically, if you want to see the relationship between variables, you can use correlation or linear regression. If the data is numerical, if the data is categorical, you can use chi-square for relationship. For the differences of mean, you can use t-test or ANOVA. And t-test, we have two, independent t-test and paired t-test. Okay. Okay, these steps you have learned before. Firstly, when you want to conduct a hypothesis testing, firstly, you develop a null and alternative hypothesis. And then after you develop that statistical hypothesis, you try to find what is the best, what is the appropriate test to use, okay, to achieve the objective of the study. Select the best test to achieve what you want to, to test what is the hypothesis. So you select the appropriate test. The test that, what I mean here is like t-test, ANOVA, correlation, regression. That's all the statistical tests. And then after you already select the test, you need to determine the rejection area. Do you still remember this? You have to determine which area is the rejection area, and then after you get the calculation, the t value, for example, you compare with the t tabulated value from table, and then from that value, you can put the value in the graph, for example, like the normal graph, and then you can decide whether it is you are rejecting the hypothesis or you have failed to reject the hypothesis. Okay. For the number 4, calculation, okay, because we need to calculate before we can decide whether it is you reject or fail to reject the hypothesis. There are two types. Basically, there are two methods to decide whether the hypothesis is right or wrong. One is classical method. This classical method, you have learned it before. There are some formula that you use before. Like for example, like t-test, you have like t, the mean, you divide something with ft, something like that. Mean minus something, and then you divide by sd, and then you compare that value to the t tabulated. That one we call it classical method. But other than that, we also can convert that classical, we also can convert that value the T calculated value, convert it to probability. We call it p-value. So this is both method, p-value and classical method. This actually method to know whether your hypothesis is your null hypothesis is reject or fail to reject. These two methods. Right. This is an example that is for the hypothesis development. The null hypothesis, there is no statistical difference between the two samples. So null is always no relationship, no difference. So that's the null hypothesis. Okay. And then second, you need to select an appropriate statistical analysis. The second step, this is the list for bivariate statistic that we will touch today. I hope you still remember what we have learned before. If I give rate 1 to 10, 1 is totally forget about the lesson last year, and 10 is you still remember it. What is the rate you give to yourself? Anybody? So that I have an idea.
I think 6.
6.
Me too, 6.
6, okay. Other than that, anybody? Anybody else? Only 2 is not enough to represent for the whole population. Any more?
5 to 6.
5 to 6. Other than that, 3 only. Maybe someone from 7 to 10 can tell me. Anybody have the rate 7 to 10? Okay, what about 0? What about 1 to 3? Or 1 to 4? Anybody? So meaning that most of you have still remember the test. Maybe you have heard about the hypothesis testing or the test that I list here. All right. So after you because you want to select an appropriate statistical test to test the hypothesis to decide whether you want to reject or fail to reject the null hypothesis. Right. I would like to okay, because today is SCTL session, it is not lecture session. Okay, so I think you already have what we call it, group, right? You already have group. Okay. Okay. So for our ABM group, the total groups that I know is 25 groups. Okay. So starting from 1 until 25. Okay. And we also have like a table. For the bivariate statistical analysis. Okay, and we have about 7 tests to learn. Okay, now I would like to ask someone from maybe I would like to choose even number, group 2. Anybody? Volunteer from group 2? You have 25 groups, right? So group 2. I would like to know what is the answer for table for the second row. Independent t-test. Okay, group 2. Anybody can give me the list of RBM group so that I can choose, because I don't have the list. Anybody can share with me in the chat, please?
Hold on, doctor. I have to find for it as well.
Thank you. because you will actually the test all the tests that you should know during undergrad is only the test that I list to you. There are many actually. There are more complicated tests. But for the test that I list just now is I think is very like it's very important to know and understand for undergrad level. Even though one day you are not to be a researcher, but believe me, being a doctor, it is not only treat patient, but you also need to.
Doctor, I've sent the Excel file in the chat.
Alright, I got it. Okay, now student from group 2. I would like to listen from Sheikh Muhammad Shahid, please. So I would like to know what is your answer for.
Yes, doctor.
Yes.
For independent
so
test,
independent
right?
test. Yeah.
If I'm mistaken, there's 3. It's a random sample.
What is the purpose for independent test?
Oh, it's to compare between 2 independent groups.
2 independent group. Okay. What about the variables?
Variable is 1 numerical and 1 categorical.
So from categorical variable and numerical variable, which one is independent variable?
Independent is categorical.
Okay. What about the assumption?
Oh, the statistical assumption is random sample, and in each group of dependent variable, the distribution is normal, or sample size is more than 30, which is big.
Okay.
And it is equal population variances.
Okay. And then what about the alternative test?
Oh, Mann-Whitney test.
Okay. So Mann-Whitney or rank sum test. Okay. Okay. Thank you. So before I continue for the PET test, I would like to tell you that one sample t-test, okay, is this is actually if you have only one sample, okay, and then you calculate a mean. You want to compare the mean that you have calculated with certain mean. Certain mean, what I mean here is the average you already know, and then you compare your value that calculated from your sample with certain mean. For example, we know that in Malaysia the HB level is maybe 11, for example, for all population in Malaysia. And then you do sampling, and then you calculate the mean of HB, and then you compare the calculated from your sample with 11, for example. So this is one sample t-test. Okay. Okay, the next one, PET t-test, I would like to listen from group 4. Nurin, Jaslina. What's your answer for PET t-test? What's the purpose of PET t-test? Nurin? Right, no answer from Nurin. What about Rishika?
The function of the PET t-test is to compare means between 2 dependent groups.
Okay.
And the variables are dependent variable measured at 2 different times or for 2 related conditions or units.
Okay.
The statistical assumptions are number 1, the variable should be interval ratio scale. Number 2, the observations are independent of each other. And number 3, normal distribution. The alternative or non-parametric test is Wilcoxon sign rank test.
Okay, thank you, Rishika. Okay, so the difference between independent and t-test and paired t-test, okay, most of the statistical assumptions are the same. But for the normal distribution, for independent t-test, the normal distribution should be from the sample itself. But for the paired t-test, the normal distribution should be from the difference between the two. As we know that paired t-test is before and after, meaning that after, for example, after you, the value of after measurement, you minus with the baseline pre-one, and then you get the difference. So all the difference, you can create a graph to see whether the data is normal or not. So independent test, you have two groups comparing means between two independent groups. But for paired test, comparing mean two like different interval, different time using the same group, same population. Okay. About one-way ANOVA, I would like to listen from group 6. Daniel Hakim. No answer from Daniel Hakim. What about?
Yes.
Okay.
Me.
Okay.
ANOVA.
Yes.
So the ANOVA, the purpose of ANOVA is to compare means between more than two independent groups.
Okay.
The variable is one numerical variable which is dependent.
Okay.
And then more than two categorical variable. Yeah,
okay. Independent.
Independent.
One categorical variable actually, but there is more than two category.
Oh, yes.
Okay. And then assumption.
Assumption first is for random sample.
Okay.
And second is in each group the distribution of dependent variable data is normal or the
Okay.
sample size is big.
Okay.
The third one is equal population variance among group.
Okay.
The alternative is Kruskal-Wallis test.
Okay. Okay, thank you. Okay, for ANOVA to test for the difference of mean between two or more independent group, it's actually one way ANOVA you also can do if the category is only two, like gender, you can do. Like, it's the same function of independent t-test, but one way ANOVA you can have more than two groups. Like independent t-test, you only can have the maximum one is only two. But for the ANOVA, you can do for two and more groups. Okay? But all are bivariate statistical analysis. So one categorical, one numerical, for example, or two numerical or two categorical. So there is no like 3 or 4 variables involved together. Okay, thank you for your answer, Daniel Hakim, right, just now? Okay, the next one, I would like to ask from group A, from Nurul Hanis, about Pearson correlation.
The function, the purpose is to assess the strength and direction of association of two continuous variables. And
Okay.
the variable is two continuous variable.
Okay.
The assumption is that there is a perfect relationship between the two variables. And the alternative is Spearman.
Okay. Maybe class, you can add like the correlation there, it is general one. Maybe you can add Pearson correlation at the beginning of the table. The row one, the column, the first column, maybe you can add Pearson because Pearson is parametric test. Okay, for information, parametric test meaning that they are required number distribution assumption. So Pearson correlation is parametric test. One-way ANOVA, PECT test, independent test, all parametric test. For Pearson correlation, the alternative one is Spearman correlation. Okay, and then as your friend said, to test the strength of association between the variables, independent should be numerical, dependent also should be numerical, and they have like normal distribution. Actually, if you it's easy to remember about assumption, all need normal distribution, except for chi-square and maybe simple linear regression. But all actually need normal distribution, and also they need also random sample. It's actually random sample. So they already know two assumptions of the parametric test. What I mean parametric test is all the test here is parametric test except for the chi-square. Chi-square it is not parametric test. It is non-parametric test. Okay. And then there are additional assumption, for example, equal variance for ANOVA, for example. Okay. Okay. The next one is simple linear regression. Simple linear regression. I think this topic is only revision about the previous topic. So if you have any question, can ask me anytime. Okay, I would like to listen from just now group 8. So now group 10. Nur Adadin?
Hello, yes, doctor.
Okay, I would like you to explain about simple linear regression, please.
So the purpose is to predict the value of the variable or response based on the predictor or the variable, and then the variables is the categorical two categorical variable, and for the assumption, statistical assumption is the relationship between x and the mean of y is linear, and the variance is the same for any value of x, and the observation are independent of each other, and the alternative is different linear model. That's all.
All right, thank you. Okay. Simple linear regression, as Adnin said, to test, like you want to do prediction, like to test how change in x variable predicts the level of change in y variable. So for the prediction, independent and dependent should be numerical data. It is not categorical. Both are numerical data. So it's the same as Pearson correlation. Independent and dependent should be in numerical form. And for the assumption, yeah, it's correct. It should be linear, should be like equal variance. But for simple linear regression, it's only like it's only nice to know lah, because we are not teach student how to test the assumption. But just for your like nice to know only, okay? Because even the in postgrad level, we did not teach them how to check for the assumption. This one is like, for example, random sample, linearity, independent sample, normal distribution, and equal variance. Okay, don't worry, I will share this, like the table that I already made. I will share with you in Teams later on. And the alternative for linear regression is non-linear model or non-linear regression. This one also the things that you only know for simple linear regression is what is the purpose of linear regression and also what's the type of variable used for simple linear regression. And Madam I will touch on multiple linear regression. If you have more than one independent variable, okay, we have to use multiple linear regression. And that's multiple linear regression. You only have to know about the concept of the method. It is not the details of it. Unless if you are doing your research later on, you need that method. You have to learn more how to conduct it, how to perform it in software. So that one, if you use this test during your research later on. All right, for the last one, for chi-square. Okay, for the chi-square, I would like to listen from Muhammad Hafizul Iman.
For chi-square,
Okay.
the purpose is to compare proportion or association between two variables.
Okay.
And the variable is both categorical.
Okay.
And the statistic assumption, random sampling, categorical variable, and independent variable, as well as expected frequency of less than 5%. Less than 5 is less than 20%. And I think that's alternative. I'm not too sure. I think it's the Fisher exact test.
Okay. So yeah, it's Fisher exact test. But for JAS, because you are using JAS software later on, there is like Yates correction. The Fisher exact test, we don't have the test in the JAS statistical test. So there is alternative one, Yates correction. So Fisher's exact test and Yates correction are the alternative test for chi-square. Okay, so chi-square, you want to see the association between two categorical variables. And you also can test whether the difference of, like your friend said, rates, to test the difference of proportion also can do. And rates also, you can compare the rates between groups also you can do by using chi-square. So in summary, chi-square to test association, to test the difference of rates, to test the difference of proportion. So all the aim you can do by using chi-square. Independent and dependent should be categorical, and for the assumption, for example, like random sample, the variables should be categorical, and the expected frequency of less than 5 should be less than 20%. All right, so I think we have covered all tests. Right, maybe I can continue a bit on this one. Only like summary for you, statistical analysis. If you want to compare means, you have two groups, you can do independent or paired t-test. Two group here, it can be pre or post. Pre one group, post and one group. Paired t-test you can use. If you have independent group like gender, male and female, you can do independent t-test. If you have more than two groups, you can do one-way ANOVA. For the association, if it is categorical variable, both categorical, you can use chi-square, and chi-square is a non-parametric test. If data is continuous or numerical, both are numerical, dependent and independent, you can use regression and correlation. And regression, you want to do prediction, how increase in Y if one increase unit in X, or how change in Y if one increase unit in X. So one unit increase in X, so you can do regression. Correlation, you want to see the strength of association between the variables. The variables here are numerical data. All right, so this is the summary. Okay, okay, this is how you can find what is the critical value or what is the rejection area. Okay, and for the significant level or for the alpha error or significant, we always put it like 5% or 0.05%. So that one is actually significant level. If the p-value is more than 0.05, if the p-value is more than 5%, so we are failed to reject the null hypothesis because the p-value, okay, the p-value is range from 0 to 1, and p-value is the probability of the null is true. The null is true. So if you have like probability, as we know that probability is a chance of getting male from your class, for example, is lower than getting female if I select randomly. So if you have higher number of female, so meaning that easier to be selected. Okay, that's the probability, we call it. Total number of female divided by total of the class. So that probability. Same goes to here. P-value is probability of the null is true. So if you have more, the P is more than 0.05, and then we can say that the null is true. You are not able to reject the null hypothesis. More than 0.05, the null is true because you are test on the null hypothesis. Okay, so if you have less than 0.05, a small p-value, so you reject the null hypothesis because we can say that the lower probability, the null is not true anymore. So p-value more than 0.05, fail to reject, and less than 0.05, you are rejecting the null hypothesis. All right. So the critical value that we put, or we set it significant value. Critical value here is the same as significant level. You put it, you set it from before we do the test, we set our significant level. And then from significant level, which is 5% usually, okay, memang tak ada lagi, there is no other than 5% yet. Until now, there is no 10% or 1%. 1% there is 1%, but other than 1 or 5, there is no more other significant level we are set for the statistical test. Okay, so before we do the statistical test, we set the P for we set the significant level first, and then from the significant level, we know that what is the critical value. If we are doing a classical method, okay, classical method, we have that value. But if you are using p-value, as I said, we have two approach here: p-value or classical method. P-value, the critical value is always 5% or 1%. Okay, critical value here is actually referred to the classical method, which is there are some value like you have to find in the table previously. That one is classical method. Okay, so significant value is always 5%, and we are comparing the significant level or value, which is 5%, with the p-value. Okay, if less than p-value, less than 5%, so we are reject the null hypothesis, rejection area. If you are more than 5%, you are not able to reject the null hypothesis. Okay. Can you please try this? A study is conducted to examine the clinical efficacy of new antidepressant. Depressed patients were randomly assigned to either placebo group, a group that received low dose of the drug, and a group that received a moderate dose of the drug. After 4 weeks of the treatment, the patient completed the BDI score. Okay, this is a score. The higher the score, the more depressed the patient. What is the statistical test can be applied to achieve the above the study objective? A, B, C, or D?
Is it ANOVA?
ANOVA. A.
Okay. A, okay, so the answer is A, ANOVA, because there is still 3 group here, and then the dependent variable is numerical data, which is score. Okay, the answer is A. What about this one? A researcher conducts a survey to find the association between family history and hypertension status. A chi-square test was performed with p-value of 0.03. So the chi-square and then the p-value that they got is 0.03. What is your conclusion if the significant level was set at 5%? So
Reject
Reject.
null hypothesis.
Reject analysis.
reject the null hypothesis. Okay. So p-value less than 5%, so we reject the null hypothesis. So, and then we can say that hypertension is associated with the family history. So today about this topic, can we have a quiz? Okay, where is this? Is the I will put it in the chat. Is it okay?
Okay.
Yeah. Okay. So can try to do it. I have paste the link there. Okay, you can do, and then maybe I give like 1.5 minutes per question. So you only need about 15 minutes to finish it. All right, don't forget to put your metric number. You can start now. Okay, we will stop at 8:53. Okay. 3 minutes left. One more minute. Less than 10 seconds. All right, 53. All right, so now I got 92 respondents. Okay, let's discuss it. Okay. Okay. A researcher wants to determine if every secondary school in Selangor has the same school dropout rate. The researcher should use a chi-square test for this study. Okay, the answer is, because this one is rate, rate between school, so the answer is true lah. Okay, and then the next question. The researcher is conducting a study to see if an experimental medication decreases mean cholesterol level. Correlation is an appropriate test to use.
True.
Okay, so what about this one? What is the best statistical test? So because of,
Doctor,
yeah,
I have a question about the chi-square one.
okay.
When we're talking about rate of school dropouts, isn't that a numerical value?
Okay, because the rate itself, is because like we have different. Let me look at back the question. Okay. Here the rates here, we have like categorical yes or no. So when we have a table, we will have like in the row secondary school, and then we have like how many, it is not numerical, like yes or no. How many students drop out and how many students continue. So there is like 2 columns for this variable. And then if we look at like maybe you want to know, maybe you think about like percentage, is it?
Yeah, doctor, because it wasn't specific. You could assume anything.
All right, but as I said, chi-square you can comparing you can compare the rates of proportion. It is not like the mean of rate for each school. It is not like that. Meaning that for each school there is certain rate. Second school they have certain rate. It is not like mean of rates. If you are like using numerical data, like for example like percentage, you need the percentage of mean of percentage. For example, now you have 25 groups, right? In your class now, 25 groups, and then you have score for this quiz, and then I get the mean of score of each group, and then I compare between all the group 25. Is it like the same or not? That's the difference between rate here. Rate is only one value for each school. It is not the mean of rate, not like that. Understand? So rate here is how many students drop out and how many students not drop out, and then from that number we can get a rate. Same goes to any variable that having only two category like this, yes or no. This is not a mean, so that's why the answer is chi-square. Okay. All right. So the next one, this one decreases the mean cholesterol. So the answer is correlation. It is not an appropriate statistical test to use because decreases the mean cholesterol level. So meaning that one study and then see whether cholesterol is increased or decreased, or is it the same. So the right statistical test here is PET test. The answer is false for the second question. For the next question, if the p-value is 0.13 and the level of significance we set is 5%, we fail to reject the hypothesis. So the answer is true, right? Because it is less than, this is more than 0.05. We have failed to reject the null hypothesis. So most of you have correct answer. Next one, if one ANOVA is used, if a one ANOVA test is used, and then the p-value is 0.001, and then the significant value is set as 5%, there is evidence to conclude that all the means are different from each other. So, okay, this question is quite tricky actually. Okay, if the p-value for ANOVA is significant, okay, it is not all the means are different style. It's only, we cannot assume that all mean are different. ANOVA, if the p-value is less than 0.05, meaning that at least one pair of the test of the group have difference. Maybe you have 3 group, 1 versus A versus B, B versus C, and A versus C. So we have 3 groups. It is not all have difference actually. At least one pair. For example, maybe A and B is different, but B and C not different, and A and C not different. The result is also significant. So the answer here is false. Okay, it's quite tricky lah this question. I agree. Okay, this one. If the equation of regression line that relates percent blood alcohol reaction time, this is the equation, then the slope tells that for every % increase in bad alcohol, we can predict the reaction time to go down by 1.3 millisecond. This one is correct lah. The answer is true. Okay, because we can see here, go down. So because of negative 1.3. And then this is actually the slope. This is the slope. And then this is the y-intercept. And then majority of you answer correctly. Okay. But next question, ANOVA is an appropriate statistical to examine the efficacy of 3 drugs in lowering systolic blood pressure. Okay, most of you correct. It's true. The only assumption for chi-square test is that all cell must have an expected value at least 5. No, here is expected value at least 5. Not all cell, but 20% of the cell only. So cannot. So meaning that cannot must be less than 30%. Meaning that if you have expected value, in that cell you can have that expected value of less than 5, but must be less than 30%, meaning that most of the cell have more than expected value more than 5, so not all. Okay, so the answer is false.
You said 20%, right? At least 20%.
Yes.
Alright.
Okay, not all cell, it's all cell, meaning that 100%. So meaning that not more than 20%, not more than 20%. So expected value is less than 5, not more than 30%. So meaning that 80% of the cell must have expected value at least 5. You understand that?
Yes.
Okay. Okay. Okay, this one we are comparing HbA1c before and after an intervention, and then the appropriate statistical test is PET test, because before and after. Okay. So if in a study of a special diet, the BMI of 300 students are measured at baseline and after 6 months of the special diet to evaluate whether the diet is effective in reducing BMI. Okay, and then the Wilcoxon sign rank is an appropriate statistical test to use. Okay, the answer is, actually the answer is false, because the 300 student is more than enough to use parametric test. So what a statistical test that you can use is PET-T test, because 300 student. The assumption for PET-T test, even though the data is not normal, but if you have more than 30 samples, you still can use for the PET-T test. So the answer is false lah. Alright, the last one, after performing a t-test for comparing of mean, we obtain P equal to 0.0259, and then we reject the null hypothesis. So it's true lah, true. Okay, it is less than 0.05. Alright, so.
Doctor.
Yes.
Can we look back at the linear equation question?
Sorry, which one? Number previous.
Previous one, yeah.
This one.
No, not this one. The one where we have y equals to 36 minus 1.3.
This one?
No.
This one, right? This one?
Further up. This one, yeah.
This
the
one.
question said that the reaction time to go down by 1.3, right? But that's not true. The reaction time goes down by 36 minus 1.3.
The answer is true. Why? Why you said it's not true?
No, because you said that the reaction time to go down by 1.3, but that's not the exact equation. What it goes down by 36 minus 1.3.
Okay.
For every % increase in blood alcohol.
It still decreases 1.3 regardless, because 36 is a constant.
Yeah, like this. Okay, for information, okay, this is for your exam later on also lah. Okay, so this one, this is the slope. This one, this is actually how much is changed in y if x is increased by 1. This is the change. But if you are doing that one is the change lah. But if you are doing prediction, you have to use all lah. For example, what is the x? Maybe 10, for example, and then you can predict what is y. But if you want to talk about changing the difference each unit, okay, 1 unit increase, this is the 1.3 here. It reduced by 1.3.
Okay, so when we just talk about the relationship between y and x, we just ignore the constant.
Yeah.
Okay, all right. Thank you, Doctor.
All right. Okay, any more questions?
Doctor, I have a question. For BMI test just now, for Wilcoxon, it is that alternative for PET test, like when to know to use PET test and when to know when to use Wilcoxon.
Okay, let me see the question. I think that's the okay. This is Wilcoxon sign rank test. It is an alternative test for PET test. You're right. For PET test is parametric, but this one is non-parametric. Okay. The assumption for PET test is the data is normal or the n is more than 30. So because of 300 students here, there are such a large number, such large sample size. So we can use the PET test. Because for non-parametric, usually we use for smaller sample size, and for your information, for parametric, it's easier to interpret compared to non-parametric because they are not using mean, but they are using the other statistic, for example, like median, for example. Okay, so for interpretation, that's why we like to use parametric. One is because they are using mean, average, easier to interpret, and also because of big data here. This is the reason. If you have, for example, if you only have 20 sample, and then you can use Wilcoxon sign rank. Okay, but if you have 20 sample, for example, 20 sample, you have to check for the normality first, whether it is normal or not. Even though you have 20 sample, you still can use PET parametric PET test if the data is normal. If the data is not normal, you can use Wilcoxon sign rank. But for here, 100 students, you don't have to check for the normality test because it is more than enough. Because the assumption is the data is normal or the sample is more than 30. Are you clear with that?
Yes, doctor. Thank you.
Doctor, so if it's 30, we need to compare other statistical assumptions, right?
If they are not, okay. When you are doing your study later on, yes, you have to check everything for assumption. But for the exam, sometimes, for example, here kan, I am not mentioned about the normality kan, but you still can use sign rank test. PET test. You still can use that. But most of the, all the question like we have like hint whether it is parametric or non-parametric, and even though if we are not give hint, meaning that the option must be like in similar similar test. For example, parametric. For example, like our just now we have here this one here, not mentioned about the data, whether it is how many sample also. We don't know about how many sample right here, but even though you don't know about how many sample and how the data is distributed, we still can use ANOVA because we are assume that they have the same characteristic lah. And then if I put everything here, maybe like your question is very long. But this one is like, you can think lah, even though we don't have any number of sample here, okay? Because of the purpose of the test itself. Alright, student, I think that's all for today. We will meet again.
Doctor,
Yes.
for the exam on Friday, do we have to review the calculations on t-test, chi-square, like the ones we did in year 2?
No. There is no such question. There is no calculation for that. For my topic, only one question you need to calculate. And it's very simple. You don't have to use calculator. You can like you can guess the answer without using calculator. For example, like 10 minus 2, for example, 5 is easy. You don't have to use calculator. Same goes to this topic, only all the concept. Okay.
All right, doctor.
Any more question? So how do you think about this topic? Is it difficult or is it okay? Okay, I give rate. I want you to give rate about 1 to 10. So how do you think about the difficulty of this topic? 1 is easy, 10 is difficult. So what is your answer? Anybody?
I think 5 better.
5. All right.
For me,
Okay. Sorry, I couldn't hear you.
it's 6.
6. Okay. All right, it's okay. So mean that like, even though it is not represent all. Okay, I think that's all for this morning. I will answer the question because some of you like asked me about the sample size correction yesterday. Yesterday I took half day leave, so I'm leave actually in the afternoon. I cannot answer all the question. Maybe we can discuss it this afternoon. All right. So, yes.
Just one last question. The
Alright.
one on rates, like rates. So if we see rates in a question, should we assume that we can use chi-square, or will it depend on the table given?
Okay. It's because of the rates, kan? The rate, it is not, as I said, it is for each school. Okay, for each school, we have rate, different rate. For example,